So yeah. So as I was saying, what went wrong in the hyperinflation episode, or what goes wrong in any hyperinflation episode? It's trust. So money starts by being something that the government says, oh, you can use these bills, and they're for practical use. It's easier to carry them instead of carrying a bag of gold coins or metal coins in your pocket, and it's less risky. And to have even a checking account and all of these things make it easier, ATMs and stuff. So, but the trick is once the government says, "Oh, by the way, now that money is being used by everybody, we're not going to worry too much about being convertible," and it works as long as people trust that there isn't a huge amount of money in circulation. But if there is at some point mistrust, if people start to think, oh, maybe money isn't all that useful anymore, or also all that valuable anymore, then since you cannot convert it back, then people start to rightfully so be freaked out a bit, and they may start to want to get rid of it completely. So uh, this really the last time that we had this convertibility change was in the 60s. So you may have heard about this episode of when the US printed a lot of money to finance the reconstruction of Europe after World War II. But then at that time, there was still the gold standard, and people still trusted the fact that no, there was not more US dollars circulating than the amount of gold in reserve at the Fed. But at some point, with the Marshall Plan and on all this these lending that went on, people started thinking maybe the American government is trying to print a lot of money, lend it to us, and then we use that money to pay them so they can invest back in Europe. So that's good for them, but maybe they do that and they overdo it. So maybe there's so we can't trust that. And there was this famous episode when De Gaulle said, "Oh, yeah, I'm not sure anymore about this the value of this US dollar. So let me get back my gold." So he used the French Navy warship and put, I think it was 150 million US dollars on the ship, and send it back to the US and said, "Okay, you give me my gold now." And they said, "Okay, good. If you want, you can have your reserve. That's your goal. That's what we agreed to." And then they said, "Okay, well, let's continue." So they sent another ship, another ship, another ship to collect their gold. And at some point, it's a bit like a bank run. So if everybody wants their deposit, the bank has to give back the money. Then uh, but the thing is, the bank overlent, and that's the same thing for the U.S. Fed. So they overimprinted money. And at some point, it was Nixon in '71. He said, no more convertibility. So okay, you caught us. We printed too much money, and now it's just floating rates, and we stop agreeing to give you gold because we're out of gold. So that was the last, yeah, in '71. That was the last time when the gold standard was abandoned. No, it was not the first time in history that convertibility was abandoned. So Kublai Khan, famously, when he invaded China, he stopped. He said, "Okay, let's." But that time you were using iron money, so iron is quite heavy in your pockets. And he said, "Oh, let's just use paper money without anchor." But then when his dynasty went away, then they switched back to gold money. Okay, so what? So how did they do it? How did they manage to end hyperinflation? Well, they said, okay, the problem is people don't trust that if they hold money, it's worth anything. So what we have is to make them believe again that it's worth something, that by law they can exchange it for something valuable. So what they did is they said, okay, well, they didn't have a lot of. So for a government, you need to. It's like if you go to a payday, yeah, somebody who's a lender who's going to want to lend you money. So he says, okay, I agree with to lend you money as long as you give me something in guarantee. So then you can give your gold watch or something. Well, it's the same for the general economy. So the government needs something to give in exchange for money in case people ask for it. So then people are going to think that it's worth it. So what they did is, okay, we don't have gold, but we can try to have it backed with real goods. So they said, okay, it's going to be real goods that are land used for agriculture and business. So they said, okay, if you agree to to use this new currency that we emitted, the Rentenmark, um, uh, then uh, then you can use it because if you want to exchange it for something, then we give you some agricultural and business land. So then people say, okay, fine, I'm going to use the Rentenmark because I trust it has a value and the government cannot print an infinite supply of it, and inflation speculation stopped very soon after. And also, of course, the government has to, since it's by law that you have to give up something in return in exchange for money, then by law you cannot print a huge amount of money. So yeah, so they stopped overprinting, and when they introduced this new currency, then the exchange rate was 1 trillion paper mark was equal to one Renton mark. Yeah, and 4.2 Renton mark was $1. So this completely stopped hyperinflation. So it was called the miracle of the Renton mark. Um, yeah, and then they finally in 1924 they introduced another new currency, the Reichsmark, which was backed by natural resources, coal, iron, and gold. So as long as you can say by law, okay, this currency is going to be backed by something, then fine. Okay, so let me switch that. Maybe if we have time, we go back over it. Yeah, this is hyperinflation in Zimbabwe. This is why we use months to look at the inflation rates when it's hyperinflation because it's just so crazy high. So this is the price of yeah the value of the Zimbabwe currency month to month during the 2008. So you see, it's just yeah in a few months there, it's just skyrocketed the well, or rather, it crashed. Of course, it's very difficult to measure these things. So yeah, this is work by Hanke and Kwok and the Reserve Bank of Zimbabwe to estimate this value. But of course, it's just so fast, and you don't have good measure for them. Um, yeah, and peak month was 70 so million, yeah, 70 trillion, 79 trillion percent. Yeah. Okay, so now let me just talk about Brazil. What's fun about Brazil is the fact that I just told you that what you need to convince people that there will not be inflation is to back up your currency with something real, something that and 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 that people trust that if they lose faith in their paper money, then they can just go back to the bank and ask for this real thing instead. There is one notable exception. It's Brazil. That's a very interesting case. When how the hyperinflation started by the project of, well, many things, but basically the project that restarted was the goal of building this new national capital in the center of the jungle that was called Brasilia. And yeah, they didn't have, at some point, you want to build a city, so it's, you can imagine, it's very expensive. So they started the project and soon realized that they were out of mean to build it. So they started printing more money to build it. But as you see, so the project started in the 50s, but and then money started being issued more and more. But the hyperinflation release just started in the 1980s, because it takes time for people really to realize that something is wrong. That, oh, maybe there are too much money supply in circulation compared to the amount of goods. But so it's something, if the government wants to trick people and say, oh, I'm going to just print a whole bunch of emit a whole bunch of new paper money and finance stuff with it, or or just lower interest rates so that that private banks want to lend more to people and issue more money this way, then it takes a bit of time for people maybe to realize what's going on. By the way, in modern central banking, what we say is we never try to trick people. We say in advance what we're going to do if you're the central bank. But back then, that it was a different story. People thought we can maybe create a surprise inflation. Yeah, so it's really back in the 80s that it started. And you see, so it's nothing as crazy as what it was in Hungary, for instance, but still the peak month inflation was 82%, which is quite high. But and the thing is, it was prolonged. So usually in hyperinflation cases, you have like 1 month, and then it spikes, and everything goes very bad. Here, it's a multi-decade thing. It's just on and on and on and on and on. Always high monthly inflation. So what was tricky about this is that everybody knew that inflation was the norm. So you expected that, yeah, of course there's going to be inflation. That's what's going on. So stores would change prices regularly to account for inflation, and it just settles in people's mind that there's going to be inflation. So when that starts, then you can see it's very difficult to end. All right. So first efforts to fight hyperinflation was quite fruitless. So what they tried to do is freeze prices, but then people said, okay, if you force me to sell my good at a price that's lower than the price I would like to sell it, then I'm just going to not sell it. And they hid the merchandise and under the counter and waited until the price freeze was over so they could start selling it again. So every time you try to, if you're the government and you try to coerce people, it's just so difficult. No matter how sophisticated your plan is, people find ways, are smarter than you, and they find ways to counteract your plan. Yeah, and then there was the color plan in the 1992. So they they tried to replace the existing currency. They froze 80% of private assets. Why? Because as I said, people anticipated inflation. So if you're a bank and you know that there's going to be 100% inflation or 80% inflation, and you still want people to put money in the bank, then you know that I'm better off offering a good nominal interest rate of like if inflation is 80%, then my nominal interest rate has to be at least 80%. Otherwise, it's like people are losing money if they put money in my bank. So they offer higher interest rates. So sometimes nominal interest rate of 2,000% or more. But you see that once this starts, then it just anchors anticipation, and then it's something that goes on forever. If nominal interest rate goes up, then the bank has to so deposits so yeah so it anchors the fact that the money is going to lose value. It's a bit like wages. Once you say, oh, let's index wages with price level, then it means that you already know that the price level is going to go up. So for instance, if I promise my employees that I would pay them 5% more next year and 5% more next year, then I'm better raise my prices by 5% more next year and 5% more the year after. Otherwise, I'm going to pay lots in wages and lose money because my prices haven't changed. So it's the whole wheel of inflation is just starting to be impossible to stop. Yeah, so they put extremely high taxes on financial transaction to discourage them. Index taxes, but because that's something that often happens is if there is a very high inflation, then the government cannot finance itself through taxes. So they need to need to start printing more money. So a way to not do that is to index taxes to make sure that they have enough taxes. So did all these measures work? No, the president got impeached. And between 1984 and 85 and 1994, so the inflation rate was estimated to have been around yeah this number that I'm not going to try to read to you, but yeah, it's a very bad state of affair. So what's the problem there? So the problem there is a problem of expectation. So people expect that prices go on forever because it's always being the case. So there's always, so this is percentage per month of inflation. So it's always have inflation above 20%, say, per month. Then people always know that they live with that. So the problem is it's a way of life for them, and even if you try to do something about it, it's just prices always increase. If you ask people who lived through that period, they said, yeah, that's normal. It's we wait in the store that they change prices, otherwise otherwise we lose money. So what was the solution? The solution was, so they asked two economists that studied, I think, in Chicago, two Brazilian economists. They said, okay, we have this hyperinflation problem. What should we do? So then the economists said, well, the problem is expectation. So what you have to do is to anchor anticipation, change people's mind. And as we've seen, that's somehow even harder than changing real things like so investment or capital quantity or stuff like that. That's concrete things, but trust is very difficult to establish. And once you lose it, once people stop trusting you, then it's just how can you say, oh yeah, please trust me again? That's please. Sorry about this. Okay. Yeah, so what they said, okay, so what we need to do is create a virtual currency. Our virtual currency is called Unidad de Real de Valor, so URV, and it's just going to track the real value of things. So, for instance, so the price of an apple is going to go up and up and up over time, but the in Unidad Real de Valor, the apple is going to always have the same value over time. And by law, you have to post the URV value beside the real price, beside the good that you sell in the store. And what happens is, well, people go shopping and they see the price of an apple in the Brazilian currency that goes up and up and up as usual because there is inflation month to month. But then they also see that, oh, this URV, it's just always the same price as it was yesterday and last month and the month before. So what happens is, oh, people realize that, yeah, it's URV looks like it's something that is stable. It's so, yeah, back then it was in Cruzeros, and what you have to then do is by law start doing all your transaction involving URVs, but just as a mean of translating the value of stuff, not as a mean of using it. And then, of course, during the same period, they balanced the government's budget. So Brasilia was built by then, or most of it. So then they didn't need to just print money. That's step one, is to, of course, not having to overprint money. And then once people really realized that URV was stable, so so July 1st, 1994, they said, okay, now let's just say, oh, we just noticed that URV prices are stable, so let's use this instead of Cruzeros. So they introduced a fiat version of the URV in the economy, and they called it the real. And today, the currency in Brazil is still the real. And look at what happened. So real plan, and then inflation completely stopped after 94, because people, so they didn't need to tell people, oh, the real is anchored to, oh, you can come to the central bank and exchange a real for gold or anything. But they managed to anchor people's expectation that the real was stable, and good enough, the real was stable, and the hyperinflation stopped. All right, so that's the last episode I'm going to talk about. Maybe Zimbabwe, if we have time, but I doubt it. So let's just summarize what we've learned so far. So two things are important for hyperinflation episodes. So first, something triggers the episode, and then anticipations kick in. And when anticipation kick in, that's when things go really bad. So what can trigger a hyperinflation? So there's just a disproportionate amount of money compared to the price level and compared to the amount of goods that you can exchange. So of course it can be a reduction in economic activity, so war, supply shock. So in the case of Zimbabwe, it was a shock of linked to the agricultural sector that created a shortage of food in the economy, a recession, etc. And then there is so that's under economy part, so the real part, if you want. And then there's another way is monetary expansion. So that's what happened in Brazil or the Weimar Republic, for instance. So it's not, well, usually you can have many different things, but in case of Brazil, it was really, they started printing too much money. Or, yeah. In modern terms, we would say quantitative easing. And it can be linked to political instability. So, for instance, in China, when we saw like last that so when we have competing governments and they all issue their own currency, then it's very difficult for trust. Um, yeah, to finance deficits, stuff like that. And then inflation's kicking, inflation anticipations kick in. So consumer and firms realize that there's too few goods in exchange for the amount of money. So they say, oh, I thought that that money had that value, but maybe it doesn't have as much value as I thought. So they start asking for more money in exchange for the same quantity of good. So prices start to rise. Retail prices start to rise. Nominal interest rate have to adjust to still convince people to put money in the bank account to accommodate anticipations. And then there's this effect called the Olivera-Tanzi effect, which is that hyperinflation makes it harder and harder for governments to collect enough money to finance the normal operation of the government. So it's even more tempting to issue even more money because, of course, the central bank can so you get access to it. So that's senior edge, and you can use it to finance your expenditure. By the way, you know what seigniorage is? Have you heard about this? Seigneuriage?
No.
In macro classes in previous
Nope.
years? Okay, so let me say it real quick. So imagine that there's no central bank independence. I'm the government, and I decide how much money is issued as well. So I can do two things to finance myself. I could, uh, well, if I don't borrow, for instance, so I can either collect taxes and then use that to finance services and the government, or I could print money. And is that money free? Well, it looks free because I decide how much money I print, so I decide how rich I am. So it looks like it's free for me, but it's not free because it increases the money supply compared to the same amount of good in circulation in the economy. So it reduces the value of money. So then everybody else that had some money at home and that were expecting to use it to buy stuff, now the value of that money goes down. So it means that instead of taxing something like work or taxing goods, if you have value added tax or if you have income taxes, for instance, to finance the government, then it's a tax on the value of money. So it's like if you're taxing everybody who holds this money right now. And of course, so you can do that if you have many people who hold that money and are ready to accept it. But you cannot do that, say in Europe, for instance, because Italy could not decide on its own to finance itself by printing money and not care about the other member state of the union, for instance. But if you control your own currency, you can do that. So of course, that's what may happen if there is hyperinflation because it's harder to collect taxes. So you have even more temptation to print your own money. All right, so now we're going to see the Cagan model. So the Cagan model is a formalization of these ideas. It's an old model, like many of the models we seen earlier, and we have to take it with precautions. I'm going to say where exactly.
Excuse me,
How much? Okay,
Mister. Hello.
Yeah, so that's Kagan's quote. So he says that the rate of change in prices during hyperinflation is has too much amplitude compared to any other part of the equations of exchange. So this is the equation of exchange. So he says that prices go up so fast that it's even faster than the money supply, or it's obviously much faster than YT here. So then it has to be because of V here. And V changes because of expected inflation. And what he says is, yeah, the way at which people change their expectation about future prices is so fast that it's that what you need is some mechanism that goes between V and T, and that's what we're going to establish here. So you have two equations that are important. So there's a question in the chat. Okay, why is it? So the question is, why is it more difficult for governments to collect taxes during hyperinflation? Because collecting taxes takes time. So in France, for instance, so if I work during a certain year and then my taxes are just collected the year after, then if there was a 1,000 or 10,000% inflation between this year and next year, then it means that by the time that the government has collected all the money from the previous year, then it's not worth anything. So you would have to collect taxes almost instantly to be able to use this money, and of course you don't have time to do that. So that's that's just a physical reason why it's just or administrative reason why it's just so difficult for governments to collect taxes, to collect taxes fast enough. Yeah. So two equations. So it's a simple model. So you have one equation that is going to sum up the dynamic. So we shouldn't be scared or anything about the model. It's not nothing too complicated. So it has two things. So first, individual demand for money, which is linked to this money to this equation of exchanges there that we already know of, and then the evolution of inflation expectations over time. And this is the magic ingredient: is how do people's expectation of prices do change in response to current events. And they can be many things. So we're going to have that there are going to be adaptative expectations, meaning that people have some preconceived idea of what inflation is going to be. And then based on the how much prices today change, then it's going to change their idea of future inflation. So that's adaptative inflation. But we could have different expectation formation. So one very popular way of doing things right now is rational expectation. Oh, I see right now, but it's been the case for many years, even decades. So what we just say is people are not fooled, and they have a perfect foresight of what the inflation is going to be in the future. But back then, so that's 1956. So he thought, yeah, it's people don't have perfect foresight of the future, which is actually the case. And they try their best to anticipate what inflation is going to be in the future based on what they see around them today. All right. So by the way, just before going further, let me just remind you of the money fact that we've seen before. Let me go back here. So looking at this, what do you think about this? Now I should go back to the quote. So the quote was saying that if we look at at what's going on in the economy. Sometimes hyperinflation is too strong, and it cannot be explained by the money supply. So looking at this, what do you think about this quote that money supply cannot explain price levels because prices change too fast? Just a reminder, this is money growth and this is inflation. Nobody has an idea? Okay, a simpler question. Just tell me what this graph says.
A positive relation between inflation and money growth.
Okay, people are sleepy, it looks like. Oh, in the conversation. Oh, I can't hear you. Try to talk now.
Do you hear us?
Oh yes, sorry, I messed with that. Okay, go ahead.
A positive relation between inflation and money growth.
Yes. So now, what do you think about Kagan's view that that prices can fly on their own without money following?
It looks like a force to this graph.
Yes. So what Kagan is saying is maybe prices can change super fast on their own just because of people's anticipation. Might be true up to a point, but it looks like in the long run there is this law of nature of or law of economy that really anchors prices to the money supply. Or maybe what happens is once prices start to increase super quickly, then because of the Olivera-Tanzi effect, then people have to start, the government has to start printing money to finance itself. So maybe the government starts printing money as a result of inflation, could be. But in the long run, it really looks like the two are linked. But still, let's go on and look at the model. Okay. Yeah, so again, as a reminder, so MT is the money supply, VT is velocity of money, how fast people want to use their money to make transactions. PT is the price level, and YT is the output. And this is how it's going to work. So this I changed it this morning because, or yesterday I think, because yeah. So if you downloaded the slides yesterday, so this may have changed. Yeah. So what happens is you have something that triggers inflation. So change in M, Y, or R. M is the most likely. So government issues a lot of money supply to finance deficits. Why? It may be because there is some recession, for instance, or some shock that affects how much goods are available to exchange. Change in R, it could be, but it's yeah, we don't have to really think about it too much. Um, okay, and then so what this means? So imagine that it's an increase in money supply. Then people realize slowly, but at some point they realize, oh, there's too much money in circulation and not enough goods. So I should so if I'm some shop somewhere, then oh maybe I should raise my prices because I don't. So before I would have said okay, one apple is worth one cruzeros. I don't know, but now I think cruzeros are not good. So you have to give me two cruzeros for one apple because my apple is worth more than I thought. But then if I'm the only shop who's doing that, then okay, fine. I can still then use my excess cruceros to buy at other shops. But then I go around and look and to the other shops, and everybody's changing their prices. It's not just me; it's the general level of prices that change. So then and then I was that's really weird. I changed this arrow there. Anyways, yeah. So it's fine as it is. Yeah, and then the trick in Kagan's model is how changes in prices today, so inflation today, affects expected inflation tomorrow. So people start thinking, oh, maybe if prices increase, oh, maybe they're going to increase even more tomorrow. And that's not entirely sure because it could be that that there's some recession right now, but then things go back to normal. And then, so maybe there's excess money supply compared to the economy today, but uh, next year things are going to be back to normal and the prices don't need to change all that much, or they could go up to this year, but then go back down next year. What matters is that people start to think that, oh, if prices went up this year, they're going to still go up next year. That's the trick in the Kagan model.
So it's a vicious circle,
It's what?
a vicious circle,
Yes,
like
exactly. It's a vicious circle. That's exactly what's going on. So then, if you expect inflation next year, what do you do? Well, you know that then you shouldn't keep too much money with you because it's going to lose its value. So you want to keep your value in some other mean, or here put it in the bank and ask for a high nominal interest rate to make up for. So what you want is to get rid of money as soon as possible because you think that if you keep it, you lose value. So that changes the velocity of money v. People say, "Oh, I don't want your money. I don't want to keep it." So the amount of money that people are willing to accept is even lower than before, or rather, they instead of paying 2 cruzeros for the apple, then now I ask for 3 or 4. So then it changes again my expectation of inflation tomorrow even more, and that's a vicious circle. So it's a self-fulfilling prophecy in a sense. It could be that you don't even have any shock, but I just convince people that there's going to be inflation tomorrow, and then people want to get rid of their money. So then prices change today. So then expectation of inflation changes even more tomorrow. So you see that it's just in people's mind. So it's essentially putting some mechanism to what we've seen in the previous model, the OLG model. What we were saying is once people think that the goods that they have is going to not have as much value next period, then right now they don't want it. So right now the value of the good goes down. So here is it's the good is money. So if I think that money is going to have a lower value tomorrow, then I don't want to be the to be the one who lose my value. I don't want to be a sucker and to to uh, to have losses. So I want to anticipate that because I'm smart and to not want money today. So the demand for money today goes even lower. Again, this has to do with how this link goes, how this link works. In Europe right now, do you do you lose sleep over the possible inflation in the future? I'm asking you, do you think it's something that may happen or not?
With the debt, yes.
The debt of European countries?
Yes.
Okay, yes, but so it's always possible. But the thing is, so inflation is super low, and it's been low for so long that yeah, it's always possible. But so my point is, in some countries like Zimbabwe, for instance, or Brazil, people know that inflation may be possible and they are looking for it. But in Europe, I don't. Yeah, I think the coronavirus is something that's more in people's mind than possible inflation, for instance. Well, it's always good to keep or to be vigilant, but yeah. All right. And how is going to be this link between prices and velocity of money? It's going to be this link here. So velocity is going to be a positive function of nominal interests. It it could it could be some other mechanism, but here we use this because we're going to have this to be able to create a link between V and P through interest rates. So how do we do this? When we say the following. So if nominal interest rate goes up, then it means that I want to put more money in. I want to put my money in the bank because it's going to fluctuate to fructify and give me value over time. So I want to not keep money. All right. So people want to keep less money in their pockets. So then it means that velocity is going to increase. So people want to get rid of money as soon as possible, as soon as they have it, or rather, what they want is to take out money from the bank and use it very quickly, and then put back money in the bank. And so, where does inflation go? Appears? Well, it appears here because nominal interest rate is real interest rate plus expected inflation.
Sir?
Yes?
So velocity of money describes how fast money change goes from one hand to another, right?
Yeah.
But if we suppose that the interest rate goes down, so we could say that people would get back their money from the bank, and so the velocity of money would increase too.
So it's velocity of fiat money, right? It's paper money.
Okay.
So so the thing is, what's going on is, so imagine that I can put my money in the bank and receive a 20% interest rate. So that's genius. That's incredible. So I'm very happy. So what I want to do is, oh, I have to buy milk today. So let me go to the ATM and then run to the store, use my money to buy my milk because I cannot buy my milk using my my savings account. I have to use money to do the transaction, and then I rush back to the bank and put back my money into the bank account to have this the good interest rate. And then the guy at the store who took my money, then it's the same thing. either he wants to spend it super quick or put it back in the bank too to make money. So the amount of money M that people want to keep in their pocket is very low. So that's what's going on.
Okay. Okay.
Yeah. So this equation, of course, is nominal interest rate I is real interest rate plus expected inflation. So now what we can do is just substitute this. So the equation of exchanges is this. And now instead of having, so I had velocity, I'm going to just substitute alpha I. And then I'm just going to substitute, instead of I, I'm going to use this Fisher equation here. I equals RT plus expected inflation at time t. And then I get this. So you see two small substitution, nothing crazy. If you know how to do algebra, you know how to solve this model. And then what we want to use this model for is for hyperinflation. So in hyperinflation episodes, things go very, very quickly from 1 month to the next, for instance. So much, much faster than real GDP can change or real interest rates can change. So it's really, what we can do is just say that these don't change at all. So they're basically stable. So we don't have to care about them. And by the way, this is in log, of course, it's log of so the value is capital M times V equals capital P times capital Y, and this we all took logs everywhere. So the log so what we can say is that big Y and big R are, we can just say that they have a value of 1. So in log terms, they have value of 0. So we can just get rid of them in the equation. So it's just a normalization. It's just the amount of stuff in the economy and the real interest rate. We normalize them in this equation to 0. So because we just say they are constant, so the model doesn't change at all if we do that. So the money demand equation is therefore this one. So can somebody just explain to me what happens? So for instance, if, I don't know, if expected inflation goes up, then what happens to price levels and why?
It increases the prices.
Why?
Because of the equation, we can see that if we isolate P and then we have a positive relation between inflation and prices.
Yes, but so imagine you want to explain this for somebody who doesn't understand maths at all. So in economics terms, how do you interpret this? Using what I said earlier.
But because if inflation goes up, then people will expect prices to change in the future, and then prices will increase
In the present.
in the present.
Yes, so here alpha was I just as a reminder, alpha was here. So it's the link between nominal interest rate and velocity. And inside nominal interest rate, there is expected inflation. So what happens is people expect inflation. So that means that they expect prices are going to go up. If the money supply doesn't change, then people want to get rid of their money faster. So the price level has to adjust because MT doesn't adjust. Yeah, and now so that's one equation of the model. So you see it's nothing too fancy. And then last piece what we need is adaptive expectation. So we see that the expected inflation is a weighted average of current inflation and past expectational inflation. So imagine that I expected inflation to be, I don't know, 5%, but then I look around and see that prices increase more. So I think that future inflation is not going to be 5%, but maybe it's going to be 7% or 10%. I don't know. So this is what we see. So we see that the amount of inflation expected to occur at period t is a weighted average of the expected inflation at period t minus 1 and actual inflation at period t minus 1. So pt minus pt t minus 1, that's actual inflation. All right. Yeah, so it's a weighted average between the two. So just let me. Okay, haha. Now I hid stuff, so I can ask questions. I hope maybe. Oh, sorry, that's my phone. So if people's anticipation don't change quickly, what should be the value of lambda?
One.
Yes. If people don't react to current events, if they are chill, if they are relaxed, and if they trust the government, they trust the money, then they think, oh, inflation was a bit higher than expected this year, but nothing bad's going to happen. So yeah, lambda is equal 1, and basically the inflation that's expected to occur in 2021 is the same as in 2020. But of course, if people react a lot, so if they adapt completely, for instance, they expected 5%, but there was 7%, well, they expect future inflation to be exactly 7%. So they expect that their anticipation of inflation was completely not the case. So yeah, so lambda close to 1, inflation expectations are slow to update. They put a lot of weight on past expectations and later on current realization, and lambda close to 0, so they react very, very quickly. So now we just use this equation, and we can substitute pi expectation at time t and pi expectation t minus 1 using this equation there. Pi expectation at time t is mt minus pt divided by minus alpha. And pi expectation at t minus 1 is mt minus 1 minus pi t minus 1 divided by alpha. That's the trick to solve the whole model. So let's do that. Yeah, so solving the model is finding the value of endogenous variable. Is here its price. What we want to describe is how prices change. So how people's attitude toward the value of money change as a response to past value of money, past prices, and actual money supply. And it could be actual GDP, actual real interest rate, but as we have said, it's they change very slowly. Yeah, and so the solution depends on the way the expectations are formed. So the parameter lambda here, and yeah. So one thing that that really is important to understand is that, as I said, economics is difficult because you see you're not dealing with things like billiard balls or atoms that always behave the same way. People are smart and they don't want to lose stuff, and they want to see ahead of the curve what's going on. So it can mean that they can have gregarious behavior, um, and that as soon as anticipation change for a slight reason, then it can create an avalanche of reactions. So we see that can be the butterfly effect or the chaos effect. So basically, that's what I'm saying is expectations here uh, can change extremely quickly, and it can create very catastrophic events. All right, so let's do what I just said. Let's rewrite the expectation of inflation today and in the past as function of a change in the difference between MT and PT. So that's of course in log terms, in the present and in the past. And then I can use these two things to substitute here. So I get this thing there. All right. So what happens is then what I can do is just so I have a price here, and that's what I want to describe is the price level today as a function of the money supply today and the money supply yesterday and the prices yesterday. So I have price and price. So I just have to collect terms and put everything on the price on the left hand side. And then so you can do the algebra if you want. In the exam, I may ask you to do some algebra. So I can give you a formula where you have prices here and prices there, and I say describe the evolution of prices as a function of the other variables. So if I ask that, then don't panic. All you have to do is collect terms. And so if you learn how to do algebra when you were younger, then you should be fine. Okay. So now I can ask you. So what is the impact of current money supply on current prices? So don't look at this for now. Magic, it went away. So again, my question is, what is the impact of current money supply on current prices?
It's a positive impact.
Most probably. Why I say most probably? Because I put 1 there and I put a plus, so I wanted you to say that. And that's mostly the case because that's mostly how everybody thinks about money. The thing that's tricky about this model is you see that, so this 1 minus lambda here, lambda is between 0 and 1. So this is smaller than 1. But lambda here, alpha here, I didn't say anything about it. So if we go back real quick, so alpha was just some positive value. But even imagine it's 10, for instance, then it could be that I have a negative denominator there. But that would make little sense. So how do I know it's reasonable to expect alpha to be not that large? So in a sense, it's what it shows is that an old way of doing modeling in macroeconomics, in which we just have these simple linear relationships to describe things, but they're not described by structural reasons underneath. If you look at modern macro models, they have structural interpretation. So yeah, what you have is micro foundations of your model. So you have microeconomic agents that behave in a certain way, and then you describe how it's going to result in some macro interaction. Here we already postulated a macro relation between every variable, and then we end up with this model. So we have to be careful when we interpret things. But still, yes, so mostly it should be positive. And then how should people react to, yeah. So this is just if I want to put back yt minus 1, rt minus 1, I said that they were 0, but in case you didn't agree that they would stay 0, so I can put them back here, put all this term there, and then ask something like, so imagine that I have a recession today. So how is this going to affect the price level today? What is a recession? What variable changes if there's a recession?
Y. So it is a positive effect on PT?
Yes, because I have a minus term and I assume that A minus alpha 1 minus lambda was positive. So yes, I have two little goods. So so it means that the price level has to increase. So yeah, that's about it. Then could there be a catastrophe in this model? Well, the catastrophe would be if there is a if velocity of money reacts so much to inflation that things go out of hand. A bit of what Cagan was saying, and this would occur if this denominator was actually negative. If this was negative and this was negative as well, so this would be larger than 1. And then what we would have is PT minus 1 would have, so would increase price at period T by itself. You wouldn't need any change in MT and MT minus 1. And you would you could have something crazy that goes on. So here I show you. So yeah, if you're just starting to learn econometrics, you may not be too familiar with this. But so this is an AR autoregressive model of order 1. So it's just that there is so the value of one variable at times t is equal to alpha times the value of the same variable at time t minus 1 plus some error term. And what you're going to learn is that if alpha is below 1, then it's fine. So some error at time t is going to become smaller and smaller and smaller as time goes on. But if alpha is larger than 1, then some error at time t is going to go to next period even larger and larger and larger and larger. And so this is what I just simulated with this process here. And if you have alpha equals 1.1, for instance, then this is how the process can go. It can just go out of hand. Whereas if alpha equals 1 or alpha equals 1 is called a unit root, and 0.9 is fine. So it just stays around 0. It's stationary, what we mean. All right, so I don't want to go too much in detail about this. Especially since, as I told you, a solution with a negative denominator would make little economic sense, because it would mean that the impact of the money supply on P is reversed. So if I increase the money supply, then prices decrease. So that would be strange. All right. So let me just, so this is the quiz. I think it should be not too difficult, this one, because you just use the few equations that we've seen before, or use your judgment. So one, ceteris paribus. So ceteris paribus is everything else staying the same. If expected inflation goes up, how does velocity change? If real interest rates go up, how does velocity change? Thinking about the equation of exchange, if my velocity goes up, how must price adjusts? If real output goes down, how must price adjust? Well, this we just answered it, but if you just forgot it, and in Cagan, is the Cagan model coherent with the many facts viewed previously? This I already commented on that too. So yeah, I was nice with you. I already gave you the answer. So you answer this on quiz 6, and I'm just going to fill my water bottle. Oh, so I think we're out of time. So yeah, you can answer that, and we can correct it. Ah, well, actually, I wanted to. So on Friday, I wanted to maybe answer questions, but so I have received absolutely no questions. So I think I'll answer these quiz questions, and so you can email me just to tell me what topics you would like me to cover more on Friday. Um, if you don't have a specific question, but you have just one, so I could spend some time on chapter 2, since it was just viewed with videos. So maybe you have questions on that. Um, yeah, we have since we have some. And we still have some slides to see this, but so yeah, half an hour we should be good with finishing the finance, and then we can talk about other topics.
Is it the last chapter?
The what?
Is it the last chapter?
Yeah, it's finished. No, no other chapters after that.
Okay.
Yeah, that's enough. So the final exam, it's chapter 2. I may have one question on the other chapters, but yeah, it's enough material for now. OLG model, hyperinflation, and resources, uh, Easter Island. Yeah, that's plenty for the final exam. All right, so are there any questions before we end the class? Otherwise, I will let you go to your other class. No? All right, so well, have a good day, and I see you on Friday. And tell me what you want me to cover. Otherwise, I will choose by myself. Or send
Bye.
question.
Thank you.
Bye.
Thank you. Bye. Goodbye.